Hello viewers, in today's class we are going to discuss one important concept from straight lines, right? And here we are going to discuss an important form of equation of a straight line, that is symmetric form of a line, right? So here we will derive the equation for the symmetric form of a line, and the symmetric form of a line is also known as the parametric form of the line, right? And sometimes this form is also known as the distance form of the equation of a straight line, right? So let us start and let us derive the symmetric form of a line. And here we'll also see the importance of the equation of a straight line, which is expressed in the form of a symmetric form, right? So for this, let us first consider the coordinate axis, right? So here we have the x-axis and y-axis, right? Okay. So now here we'll take a straight line which passes through some point x1, y1, right? So here I am drawing the line, and this is the straight line which passes through some point, say q, which is the coordinates are x1, y1, right? And this line is making an angle of theta with the positive direction of x-axis, right? So we have a line and a point q whose coordinates are x1, y1, and this line L is making an angle theta, right? And now let us consider a point P on this line, which may be taken as a journal point on this line L, right? So P is having the coordinates x comma y, right? So we have to find the equation of this line L when we are given that there is a point q x1 y1 lying on this line L, and this line L is making an angle of theta with the positive direction of x-axis, right? So now let us quickly see this figure. This line L is intersecting the x-axis at some point, say A, and y-axis at some point B, right? And here we have the point Q, here we have the point P, and let us drop the perpendiculars from this point Q on x-axis. Similarly, from here we can draw the perpendicular on x-axis, right? And let us join or let us drop a perpendicular from this point Q on this line, right? And suppose here we have the point N, and let us take these 2 points as M and L, right? And see, here we have the angle theta, so this angle is also theta, right? Because these QN is parallel to AL, and these two angles are corresponding angles, right? So now our aim is to consider this triangle, that is the PNQ, which is a right angled triangle, right? And we have this angle, that is angle P, and Q is 90 degrees, right? So now here let us consider this triangle PNQ, and let us find out the value of cos theta and sin theta, right? So here we have cosine theta and sin theta, right? So if we see this triangle, then cosine theta is Qn over PQ, and sin theta is Pn over PQ, right? So this is from simple trigonometry, and we have, in case of cos theta, base divided by hypotenuse, and here we have the perpendicular divided by hypotenuse, right? So now we have to find the value of Qn and see Qn is equal to ml, right? So here we'll write ml, and we can take pq as some parameter, that is r, right? So here in this triangle, the length of the perpendicular hypotenuse may be taken as r, right? So here we can take r, and see here we have pn, and here we have pq, and pq is equal to r, right? So this we have assumed here, the length of pq is equal to r, right? So now let us express the distance ml in terms of OL and OM. So ml can be written as OL minus OM, and in the denominator we have R, and here we have Pn. So Pn can be written as PL minus NL, right? So we can write PL minus NL divided by R, right? And now we can easily see that this OL is nothing but our x, right? So here we'll have x minus OM is our coordinate x1, right? So here we have x1, and here we have in the denominator r, and now here we have PL, and PL is nothing but our y coordinate, that is y, and NL is our coordinate y1, right? So we have y1 here and divided by r, right? So now from this equation and from this equation, right? So we have cos theta is equal to x minus x1 over r. We can write r is equal to x minus x1 over cosine theta, right? And from this equation we have sine theta is equal to y minus y1 over r, and we can write r is equal to, taking r here and taking sine theta to the denominator, we have y minus y1 over sine theta, right? And now if we combine these two equations, we see that this is equal to r, this is also equal to r, so both these quantities are equal to r, right? So now we can write x minus x1 over cosine theta is equal to y minus y1 over sine theta, and both these quantities are equal to r, right? So viewers, this form of the equation of the line is known as the symmetric form of a line, right? And here this form is also known as parametric form of the line, or the distance form of the line, right? And we'll see in just a moment why this is known as a distance form of the line, right? So in this equation we observe that x1 y1 is a point lying on this line L. X y are the general coordinates of the point P, or the general coordinates of any point P line lying on this line L, and theta is the angle which this line makes with the positive direction of x-axis, right? So let us now further investigate this equation. So now let us investigate this equation, and let us rewrite this equation as x minus x1 over cos theta is equal to r, right? So now from here we can write x minus x1 is equal to r cos theta, and we can write x is equal to x1 plus r cos theta, right? So here we get x is equal to x1 plus r cos theta. Let us now write y minus y1 over sine theta is equal to r, and we can now write y minus y1 is equal to r sine theta, So y is equal to y1 plus r sine theta, and we have now the value of y, right? And see what we have said earlier, that this point P is having the coordinate x comma y, right? And this P represents, or it is a representative of all the points lying on this line L, right? So we may call it the general point lying on this line L. And see the general point, that is P, is now given by x comma y, and we can now write for x, we can write x1 plus r cos theta for this x, and for this y we can now write y1 plus r sine theta, right? So this represents the coordinates of this point P, which is a general point on this line L, right? So now let us make the another observation, right? See, here we have this point Q, right? And this point Q, we can write this line L like this here, and this is L, and here we have Q, and here we have P, right? And see, in the beginning we have assumed that this PQ is equal to R, right? So this distance, that is this distance, is R, right? So here the coordinates of point P are given by these coordinates, right? And see here we have this parameter R. So this point P is the coordinate of the point which is at a distance of R from this point Q, right? So this is also an important observation from this equation, that this coordinate represents the coordinate of any point P which is at a distance of R from this point Q, right? And see, if we replace R by minus R, now this is the third observation. Now if we replace R by minus R, it means we are moving towards this point, or towards this side, right? And let us make this point P as P prime, right? So we see that if we replace R by minus R in this coordinate, then we get the coordinates of any point P prime, which are given by x1 minus r cos theta, comma y1 minus r sine theta, and this coordinate represents a point P prime which is also at a distance of R from this point, right? And but in the opposite direction, right? So the point P is at a distance of R from this point, and this point P prime is also at a distance of R from this point Q, but these 2 points P and P prime are lying opposite to the point Q, right? So when we take the positive value of R, it means the point is lying towards the right of Q, and when we take R as the negative, then it implies that the point P prime lies to the left of Q, right? So this is how this equation is a very important equation in straight lines, right? So viewers, let us apply this concept to this problem, right? And then it will be crystal clear why this symmetric form of a line is important, right? So here I am taking this problem. See, the problem goes like this. The slope of a straight line through Q 3,2 is 3 over 4. Right? So here we are given a straight line which passes through some point Q, and here this point Q is 3,2, right? And the slope is 3 over 4, right? So here we are not given directly the angle made by the line with the positive direction of x-axis. Instead we are given the slope, right? And we have to find the coordinates of the points on the line that are 5 units away from Q, right? So here if we draw a rough diagram, see we can draw the line like this. This is the line L, and we can take the point Q here. This is the point Q having the coordinates 3, 2, right? And this line is making an angle of theta with the positive direction of x-axis, right? And here we have to find the coordinates of the points on the line that are 5 units away from Q. So here we can take the point P, this point P, here this is x comma y, and see this point P is 5 units away from Q, right? So if we take this point P towards the right hand side, then we can take r is equal to positive 5, right? And if we take here the point P prime, which has the coordinates given by these coordinates, so this point P prime is also is at a distance of minus 5. R is minus 5 from this point Q, right? So now we'll apply this form, that is this symmetric form, to find out the coordinates of this point P and P prime, right? Or we can directly substitute the value of r cos theta and sin theta in these coordinates as well, right? So see here we have the slope of the line, right? The slope of the line, that is m, we are denoting the slope by m. It is given as 3/4, right? And the slope is given by tan theta, right? So from here we can directly find out the values of sin theta and cosine theta by simply taking a triangle. So here we have theta, and tangent theta is 3/4. So here we have 3, here we have 4, and by Pythagoras theorem we can find out this hypotenuse as 5, right? So now the value of sin theta is 3/5, and cosine theta is 4/5, right? So in order to find out the coordinates of this point P, we'll take this form of the coordinate, right? Because this point P is lying towards the right of Q, and this point P prime will use these coordinates, right? Because it is lying towards the left of Q, right? So we can now simply substitute the values and we'll get the coordinates. So for this point P, we'll have x1 plus r cos theta, right? So x1 is 3, this is x1, and this is y1, right? So x1 is 3, y1 is 2. So we have 3 plus r is 5. So we have 5 times cosine of theta. Cosine of theta is 4/5, and then we have y1. Y1 is 2 plus r is 5 times sine theta. Sine theta is 3/5, right? So now we have here 5 and 5 get cancelled, here 5 and 5 get cancelled. This is 3 plus 4, 7, and this is 2 plus 3, 5, right? So the coordinates of this point P are 7, 5, right? And similarly, when we have to find the coordinates of this point P prime lying in the opposite direction of this point Q, we have x1 minus r cos theta. So here we'll have simply the negative sign. So we have 3 minus 5 times 4/5, and here we have 2 minus 5 times 3/5, and see this 5 get cancelled, this 5 get cancelled. So 3 minus 4 is -1, 2 minus 3 is minus 1, right? So now the picture goes like this. Here we have Q, this is 3 comma 2, and this point is P prime. This has coordinate minus 1 comma minus 1, and this point is P, and this has coordinate 7 comma 5, right? So this is how we can tackle this type of problems with the help of a symmetric form of a line, right? And moreover, suppose we have to write the equation of this line L, we can write x minus x1. x1 is 3, and we have cos theta. Cos theta is 4 over 5, and here we have y minus y1. y1 is 2, and sine theta is 3 over 5, right? And now we can rewrite this equation as 5 times x minus 3 over 4. This is 5 times y minus 2 over 3, right? And we can cancel out these two 5s here, and we can simplify it. So this is 3x minus 9, and this is 4y minus 8, taking the cross multiplication here. And we can now write 3x minus 4y, and here we have minus 9 plus 8 is equal to 0. So this is 3x minus 4y minus 1 is equal to 0. So this is the equation of this line in the form ax plus by plus c is equal to 0, and this form is known as the general form of the equation of a straight line, right? And here I would like to mention one more important thing, that see the line L is represented by either this equation or this equation, right? And here the form matters, right? See, when we observe this line as this equation, then this is the general form, right? But when we observe the same line with this equation, that is when we write the equation of this line L in the symmetric form, then this line appears like this, right? So when we write the equation, or when we represent the line in this form, then this is called the symmetric form, right? But when we express the same line by simplifying this equation like this, then it is called the general form of the line. So what matters here is the form of the equation in which the given line is expressed, right? Because see, if we express a line in this form, say x over a plus y over b is equal to 1, then this line is known as the intercept form of the line, right? And we'll discuss this form in our next videos, and we'll also solve some more problems from this topic in our next videos, right?